Okay, welcome to Logical Clock's webinar. Tonight we have Fabio. He's going to talk about real-time predictions with the online feature store. But before we get started, just a few reminders. We're recording this webinar, so you will receive the video recording and the slides later on. Feel free to send questions using the Q&A chat rather than the actual chat button, because then this way we can track your questions, make sure we're answering them all. And feel free to send us questions because we're going to be answering questions at the end. I hope you stay with us until the end, and I hope you enjoy the webinar tonight. And if you want to follow up, Fabio's going to do a demo halfway through this presentation. So if you want to follow up the demo during it, I'll send the link here in the chat for you to sign up to Hopsworks, and so you can follow up the demo at the same time. Okay, Fabio, you can take it now.
Okay, thank you, Natalia. So, hi everyone, I'm Fabio. Today we're going to talk about the Hopsworks online feature store and how to use the online feature store for real-time predictions. A bit about us. We are Logical Clocks. We are the main developers behind Hopsworks. Hopsworks is used currently at some large organizations in different verticals, whether it's banking, betting, health verticals, where Hopsworks provides the feature store to satisfy their machine learning needs and analytical needs. Hopsworks is currently the only feature store available as a managed platform, both on Azure and AWS. It's available at hopsworks.ai. You can register for free. You don't need a credit card. You don't need to go through procurement. You get $4,000 worth of credits to get started and to play around with the platform and try it out by yourself. So just have to connect your account. Everything will be deployed within your organization. So all your data is secure, and you can access all your data and all your systems. So what is the Hopsworks Feature Store, and why an organization that is seriously invested in machine learning needs one? So the idea behind the feature store, if you take a step back and consider the feature store, not only the online part, but like as a generic aspect, what we see going and helping users and companies is that companies at this stage have developed a set of models, and they are trying to kind of productionize these models. The underlying issue, though, is that models are developed by different teams. Each team basically, before even getting to the model, needs to build a pipeline to actually do the feature engineering that are necessary for the model to actually be trained. Now, here, I would say, issues start to arise. Building a pipeline from our experience takes time, and oftentimes what we see happening at like different users and customers is that like these pipelines are rebuilt from scratch by different teams every time a new model arises. There are two main underlying issues. One is that there is no standardization of features. So like different teams might compute the similar features or the same features in different ways, making it extremely hard to actually share it across models within a team and across teams. This is an example. Like we have a bunch of models, one is credit one, churn model, and customer life cycle model, pulling data from different backend systems, whether it's transaction databases, whether it's like a data lake, whether it's a third-party systems, and for each of these models, a new pipeline is being built, and pipeline takes the data, does all the feature engineering before being able to train the model. The second pattern that we see is especially in the cloud settings where you as user of a company, you do have access to a bunch of tools. What we often see as a partner is that different teams decide to use different like systems to store those features. And this is a kind of a trade-off that we are seeing companies and customers kind of walking away from. The underlying issue is why this like provides like each team the freedom to do whatever they want. Basically makes it impossible to again share features and like unify features across an organization. So even though maybe a feature could be used because it's computing the same way as another model expects it, it's stored on whatever other system that is so hard to get it that it's probably easy just to recompute it from scratch. And so again, no standardization happening at this stage, making it harder to actually share features and so on. So that's where the feature store comes into the picture. The feature store and Hopsworks Feature Store is more of an architectural pattern even before being a product. The idea is that you have three main components of it. You have a feature engineering component, which is the yellow box that you see in the picture. Feature engineering component is basically an engine that allows you to basically build pipelines and compute features and so on, whether it is a Spark environment, like in Hopsworks case, it can be the Spark environment built in the Hopsworks environment. It could be a Databricks environment. It could be HT Insight on Azure. It can be AMR on AWS that allows you to kind of build features. The second aspect of the feature store is offline and online feature store. That basically those two combined are responsible for storing cache data for different type of use cases. Online feature store we see during this webinar to serve features with low latency, and offline feature store mostly for recording historical patterns and use it for training models and training models essentially. The third aspect is the metadata around it, especially what we see with like users and customers. Oftentimes, like the offline feature store by itself, it's like they often comes to the mentality of say, okay, we can build up ourselves. I can just have a S3 bucket somewhere with all my offline features being there, and I know where they are. The problem of that is, again, it's extremely hard to actually work and share features and use features in that scenario, because you know where your S3 features are, but like nobody else in the company knows. That's where actually the metadata that are built around the Hopsworks Feature Store actually helps out in finding out which features you might want to use, which features you need, what kind of features they are available, who is responsible for that. So we built around the Hopsworks Feature Store all tools to be able to catalog features, build up like catalogs with custom tagging, be able to track lineage across different stages of the pipeline, and in general being able to have like a good insight of what the features are and where they come from, who they own them, and what's best to use it. So these are kind of like the three legs where kind of the feature store and the Hopsworks Feature Store relies on. And that basically what's ended up being looking like the pipelines before. So like we have a single pipeline or like a set of pipelines that are actually not connected. They are independent by the number of models. The pipeline ends up being writing to the feature store, and then the feature store, it becomes the source of the data for the different models, basically. Now, this webinar, we want to focus on the online feature store and why, again, an organization needs an online feature store. So when we talk about like models, we can classify them into different aspects. So we can classify them as analytical models and operational models. The first ones, the analytical models, are essentially you have a business case where you want to generate a report. You have a machine learning model to do that. So like every day, every month, a couple of times a day, but like with essentially not low latency requirements, you go to the offline feature store, you pull out a bunch of records that you want to score, you do batch inference on those amount of records, and you submit a report, you build up a dashboard, or you build up a report and send it to someone. The key aspect in the analytical models is that the latency is not as a critical component as for operational models. Yeah, of course, you don't want your analytical model inference to take forever, but at the same time, it doesn't affect user experience. Analytical model can be orchestrated by, for instance, Airflow pipeline, again, running periodically depending on the use case. The operation models, on the other hand, is there where the online feature store is actually needed. The idea is that you have a model which is online, which is basically serving requests coming in, and those requests are coming from either directly from users or other systems within your organization. But the critical component here, the decisions and the model prediction needs to be done with extremely low latency and high availability. So service needs to be running and the response needs to come in fast, because otherwise it's going to impact user experience. So the idea is that, yeah, the user, simplifying, the user sends a request, let's say, to a website to figure it out if the user you can grant a loan, for instance, to the user. The website goes to the online feature store, fetches a bunch of features representing the customer, and then send them to the model to do inference. Again, I want to stress, in this situation, like, latency and availability is actually critical for user experience. So if you look back at the diagram before, what we're going to focus only in this webinar is essentially the top part. So how do we ingest data to the online feature store? How do we keep the data fresh? And how we consume data for models to be able to do inference and to augment the feature vector before doing inference. We also be looking at how to use the data that the feature store provides to make sure that the model is actually fresh, and figuring out when the model needs to be retrained. So this is what Hopsworks provides as an online feature store. So there are several components that are built, and they are working together to provide the feature store, online feature store experience, let's say. So on one side, on the leftmost side, you have a data scientist, a data engineer, that needs to write a pipeline that writes into the online feature store. The way you interact with the Hopsworks feature store and the online feature store is no different, is through the HSFS API. So it's API available both in Python and Scala and Java, to be able to write into the feature store. The API takes either a Spark data frame or a Pandas data frame and write it into a Kafka topic. The Kafka topic is configured automatically by the platform. The entire life cycle is managed by the platform. So if you want to create new feature groups, new topics will be created for you, and the data will be sent automatically by the library. So you don't have to configure any writer or anything like that. On the other side of the Kafka topic, we have the online feature store service. So this is a service that we develop. It's completely stateless. So you can, for instance, deploy it on top of Kubernetes cluster and scale it up and down depending on the load that you currently have right into the online feature store. The service basically subscribes to a bunch of topics, pulls data out of the topics, and write it into the online feature store. That's, in our case, is RonDB. RonDB is a fork of MDB that provides low latency, high availability, access to feature vectors, basically. Benchmark, we can easily scale to millions of operations per second. So that's pretty optimal for this online feature store use case. The sending data through the pipeline is done by sending actually Avro encoded data. All the encoding and decoding is actually taken care of again by the library of the services. So the data scientist basically, we see later an example, only sees basically a Spark data frame or a Pandas data frame getting inset. Everything else is kind of abstracted away. This architecture is beneficial because allows us as a platform and allows Hopsworks to kind of provide a way of controlling the amount of data that gets written into the online feature store. We have seen by experience, for instance, that especially new users coming, for instance, from in the world of Spark, then don't really have the confidence to configure correctly, let's say, a Spark application. And it might, say, if we didn't have this architecture, we might completely overload the storage. That becomes a problem because we said before, one of the critical aspects of the storage is actually to be able to serve actually vectors to user to be able to do inference. So the trade-off that we do here essentially is to throttle writes and be able to serve slightly updated versions if necessary, rather than actually not serving any vector at all. So that allows us to keep being idle available and be able to first and foremost answer the requests coming from the user. As I was mentioning before, all this architecture is actually deployed with Hopsworks. Users do not have to interact directly with us. They interact through the API, the HSFS API. So HSFS stands for Hopsworks Feature Store. We do have documentation available, and we do also have some examples available that covers, among other things, the how to use the online feature store, but also how to use the offline feature store, how to use for instance, the concept of on-demand feature group. So how to get data into the feature group, into the feature store from external systems like a database, S3, and any other system. The API and HSFS API are, as I said, available both as a JVM, let's say Spark and Scala language, or Python. The API are similar in both cases. In the following notebooks, we're going to see the Python side of it, but at the same time, we can find documentation to how to achieve the same on the Java side. The API, again, are the same if you use, no matter what you use, the API are smart enough to understand if they're getting a Pandas data frame or a Spark data frame and deal with it depending on what type of data frame comes in. So the first step, if we want to use the online feature store, is actually create a feature groups. So the idea is to have this method called create. You specify a name of the feature group, you specify a version, and in this particular case, you want to specify also a primary key. The reason you want to specify a primary key is that, when you're actually going to be using the feature store, like the feature vectors coming from the online feature store, you will be actually looking on a primary key basis. And if you do that, then storage is optimized, RunDB is optimized for low latency access for that specific use case. You can provide a description. There are a bunch of other parameters you can provide. You can compute statistics on the feature groups. Statistics will be computed only on the offline part. And the other one that you have to actually enable yourself is this flag called online enable. Feature groups are not by default enable online. We want you to enable online only the feature groups that you actually going to be using online. If you're doing experimentations and so on, then probably offline it's fine. What this code does, what this code hides behind all this like a 5 lines of code, is a bunch of different stuff. First of all, it creates the feature group on the storage. So it creates a feature group on RunDB. It creates all the metadata necessary for discovering it and so on, and also set up the Kafka topic that I was mentioning before to ingest the data. Once the feature group has been created, we can actually start inserting about it, inserting into it. There are mainly two use cases for, let's say, keeping data fresh on the online feature store. One is like a batch insert, and you want to do batch insert, let's say, in two cases. One is like you are doing backfilling, so you have decided that this feature group is going to be used for a model, and you need it to be online, so you're going to backfill the online feature group. The reason you will backfill it is because the offline feature group might contain 10 years of historical data. On the online feature group, you want to maybe only the last available vector for, let's say, each customer, for instance. You don't want the entire history on the online feature store. The second one is actually like doing batch insert. So the data is available online, so model can actually pull it, but the data doesn't arrive in a streaming fashion. It actually arrives in a, let's say, in a batch mode. Let's say you get a new CSV file every day or every couple of hours, then you want to feature engineer this CSV file and make it available online for application to use. So that's where the insert method actually comes into the picture. You can decide to actually store it both offline and online, or if you specify storage online, then the data will be inserted only in the online feature store. So you have this. The library provides this flexibility. The other one that actually we are integrating now is actually stream insert. So the idea is that not only data is going to be available online, but data needs to be propagated from whatever source it is to the online feature store in a low latency fashion, and that's where streaming comes into the picture. The insert stream basically takes, and this is available only for PySpark and generally speaking Spark applications, that basically takes a streaming data frame and actually writes it directly to the Kafka topic without you having to set up any sync or anything like that, allowing you basically to do micro batching and writing and doing feature engineering with low latency and write it to the online feature store. Finally, we have APIs to actually consume the features and consume the data from the online feature store. The way you would use it is actually not by interacting with the feature group, but now you're going to be interacting with a training data set. So the idea is that you have a bunch of feature groups, and you create a training data set out of this feature groups, and you use that training data set to actually define, to train a model, let's say. When you are pulling data out of those feature groups, you're not pulling data by looking at the feature group specifically, but you're pulling data by looking at, okay, I need the data for this specific training data set. And what this does behind the scenes is actually something a little bit, let's say complicated, but everything is hidden behind the API. Essentially, what it does, it goes to the Hopsworks metadata and looks up, okay, this training data set has been used, this training data set has been built by this number of feature groups. And this is the query that you need to run on the online feature store to get the same data. The query has two underlying properties, let's say. First of all, it excludes any label that you are not going to need during inference. And the second thing, it actually gets you the same features in the same order that the model expected. So you don't have to encode it in the application. Okay, this let's say these are the features that I need for this model, and this is how they are located, that they are expected. Everything is taken care of by the library by looking at the metadata. Once Hopsworks applies, the metadata is cached, so this only happens the first time you actually ask for it. So every subsequent request will actually reuse the same cache metadata, and the query will be then sent to the storage to run DB to be able to executed and returned the result to the user. Uh, in doing so, we also take care of serialization, deserialization. If you have complex types and so on, everything is going to be returned as a pandas data frame, and everything, like if you add, like for instance, complex features, like you have embeddings, for instance, or you add like mostly embeddings, those will be serialized when written and also deserialized when read from the library, and everything will be somehow like hidden behind the API. So that's the interaction, let's say, for like computing, ingesting, and consuming features from the online feature store. Now there is one additional aspect that like the feature store helps you with when you have models available and serving features to the to the users. Um, the idea is that when you train a model is that you put it in production, then it's gonna stay there forever, and okay, that's fine. The model will degrade, the data will shift, and you will have to retrain. You will have to retrain the model every now and then. Now, how do you know when it's time to retrain the model? So if you're using Hopsworks as a serving infrastructure, then every request that comes to your model will actually be recorded into a Kafka topic. That will contain data coming in, a prediction, and so on and so forth. So we have templates, and they are available actually on our GitHub organization. We have templates that you can basically spin up, and they are Spark streaming applications that basically read up the data from these Kafka topics. They compute statistics over the incoming data, and then you can compare the statistics with the statistics of the training data set. So when you create a training data set, as I was mentioning before training the model, you can also compute the statistics on, let's say, descriptive statistics, distribution, for instance, correlation, and so on. You can compute those statistics and store them in the Hopsworks Feature Store to be reused now when you actually need to figure it out. Okay, is the data coming in matches the distribution of the model, or of the data that actually was used to train the model? And if not, should I retrain my model and account for new data coming in? The Kafka topic also allows you to record data coming in and allows you to transform this incoming data to be essentially new trained in the future. And that's why that's actually where in the offline feature store we use something called Apache UDI, which is a library that allows you to basically do upsert mostly upsert. Allows you basically to write into as soon as data comes in to the Kafka topic, you can write into the offline feature store, and let's say in n weeks times or whatever time you will figure out what was actually the right value of that prediction that the model has made, you can go back and update that vector on the offline feature store with the correct prediction, and then use that vector again to redo the cycle and retrain the model and publish a new model and so on. So that's basically the complete cycle of how to use also the metadata from Hopsworks to monitor the models. I have a quick demo now to look through. This is, by the way, the GitHub organization that I was mentioning before. If you're curious about Hopsworks, please go ahead and put a star in it. As I said, we also have there with the templates for the streaming application to monitor the application, and we also have a bunch of more examples for different aspects of the Hopsworks Feature Store. So let's go ahead and jump on the demo and see how we can use the online feature store. So the first thing is Hopsworks.ai. So as I was mentioning before, Hopsworks.ai allows you to deploy clusters and configure clusters and configure Hopsworks and manage Hopsworks clusters to be able to use the feature store. You can register for free. You get like $4,000 worth of credit to try it out. And that's pretty much a 1 year worth of like workers to be able to do your feature engineering and to play around with. We do have an additional feature. So like if we quickly go through the setup, we have documentation. Everything is on docs.opsox.ai, how to set up, how to connect, and what all that field means. I want to just jump into this RunDB configuration. So opsox.ai, this is actually a features that we have in private beta. So if you want to try it out, feel free to reach to sales, and we will enable it for you. The idea is basically that this section of opsox.ai allows you to configure and manage your online feature store with much more details and much more flexibility. So the idea is that you can specify how much storage you want to need, how much storage you need to store your online features, and how many control nodes you actually want to use to manage those the online feature store. So there is also there's also an advanced configuration if you want to go a bit more into details on how to configure and flex and prepare your cluster. We can help you out with if you have any questions and so on. So yeah. Again, this basically goes through like different aspects of where do you want to have your cluster, which type of machines you want, if you want which type of instance role you want. So if you want to access external resources, this is useful. Network configuration. So if you have a strict requirement from IT to configure a specific network, that's how you can do it, and a bunch of other configuration. Once this is configured and announced, I already have a cluster up and running. This is how it looks like. This is a new UI where we'll be launching in the following weeks. The new UI is available, as well as the old UI is still there if you prefer that one. I'm not sure you will, but like feel free to use it as well. So the idea, let me go through some of the Jupyter notebooks that we have to actually see the online feature store in practice. So the first notebook is, as I was mentioning, the creation of the online feature store, of the online feature group. So this is a well-known data set from Kaggle. It's a telecom churn model with data. Let's say you're building an application that actually predicts if the user that calls, for instance, a call center is going to churn or not. So you want the call center operator to know in real time if the user calling is at risk, or and we need maybe to do something, maybe give it a promotion or something. So that's kind of the use case. So this works on a Pandas data frame, as I was mentioning before. HSFS works both on Pandas and on PySpark and Spark. So we are reading a CSV file with the data. We are looking at a bunch of the data. We are doing some feature engineering, some like one-out encoding and so on. So that's kind of pretty much standard, and there's nothing like Opsox specific in these settings. So if you have existing pipelines, for instance, you could just plug them into Opsox without changing anything except the sync or where the write happens, basically. So you don't have to re-architecture pipeline just because you want to use Hopsworks. So this is actually the only part that you need to change. So we establish a connection with the feature store. As we are running within the Hopsworks environment, we don't need to specify anything, because Hopsworks, the library figures out automatically based on the configuration of the Spark environment that we provide. If you're using Databricks, for instance, then you will have to specify where your instance is and how to connect to it, credentials, and so on. Again, everything is documented in the documentation. So again, we can set up this online feature group. Okay, here we don't compute statistics, but we could potentially compute statistics and decide which of the statistics we want to actually keep in mind, and we just save the data frame basically. That would basically, as I mentioned before, if you go back to the feature group, create the metadata for the feature group. So you can navigate through it. You can see, okay, these are all the features that have been created. We can filter for them. We can look, for instance, at provenance. We can do the opposite. Before I was mentioning, if we have a trained data set, we know which feature groups they belong to, but also the other way around is possible. So if you have a feature group, you know in which trained data set they have been used. Here I'm using it in actually in two versions of the same trained data set. So I know that the actual feature group is actually being used, and I want to keep it around and maybe not delete it and stuff like that. So this is all available as a metadata for user to explore. We can search for different things. We can actually look at the data. It takes a little bit of time to load all the data and have an idea of okay, how the data looks like. Can I use it? Is the online feature store populated correctly? What data looks like there, and so on. We can look at activity as well. Okay, this is just feature group was created, but like if we add insert and so on, they would be added and see basically sort of a Git history of all the different modifications that have been applied to that specific feature group, basically. So that's the first part of the creation of the feature group. As was mentioned before training the model, then you want to create a training data set. So in our case, we are going to be using only features coming from a single feature group. We might as well use multiple feature groups, and then we have a pandas-like API, though HSFS has a kind of pandas-like way of doing joins between different feature groups and allowing you to define arbitrarily complex joins to join multiple feature groups together and multiple features from different feature groups together. So the idea here, we basically create a training data set, we call it churn model, and we specify a version, we specify that we want a CSV file. This is actually critical for using the online feature store, is that we explicitly tell the library, okay, this is the feature that is going to be used as a label, so as a target. Then basically this feature will be omitted when you actually get the serving vector from the online feature store. So it won't show up in your inference vector. We want to have a single CSV file to make it easier for training. We can give it a description. We can decide to split the training data set into multiple aspects. So we can decide to, for instance, allocate 80% of the data set for training and 20% of the data set for testing. And again, we can compute statistics if we want to. This again, once we save it and we compute the query and so on, everything will again show up in the UI. So, and also the feature, also the training data set is actually discoverable. We have a bunch of data of when it was created, which format it is, which features they are part of it, and we can also see which of those features are actually the label of the training data set. And we can see, okay, which through provenance we can see from which feature groups actually those features come from. And again, if you notice, we didn't really have to specify anything for provenance. Everything is picked up by the platform itself. So all the, like, let's say the graph of dependency between feature groups, trained data set, and models is automatically computed behind the scenes and behind the without the user even knowing about it. And then a bunch of more data, we can see, okay, this is our configuration for the splits and how to actually use it if you want to use the training data set to build a model. The next step would be to actually train a model. So this is like a simple XGBoost model. We get the feature we get the trained data set, we train the model, and we save it, and we save the output as a Pickle file in the Hopsworks model registry. The Hopsworks model registry will be able to actually compute the final step of our online feature store journey, let's say, and will be to be able to build an actual application that allows us to use the model and the data coming from the online feature store to actually make inference. The idea is basically this application runs, let's say, outside. Like I have it here just for convenience. As I was mentioning before, you need to set up, you need to set up some credentials and figuring out, where is the online feature store instance running. So we contact Hopsworks to figure out all the endpoints and all the metadata necessary. We get the metadata for the feature store. We get the train data set that we are considering for this application. And then when the user submits an application through a post request, let's say the user submits a post request for the customer, the library goes and fetch the let's say the inference vector for the specific customer ID and uses the inference vector to actually make a prediction. So you can call Hopsworks again. It's going to call the churn model, and it's going to call the predict model to actually send it the predict method to actually make a prediction on top of that inference vector. So that basically concludes the cycle of how you can use the online feature store. That's pretty much it. Again, if you want to try it out for yourself, feel free to reach out to sales or try it out for yourself on hopsworks.ai. Again, you can try to deploy a cluster, and you can reach us on community.hopsworks.ai if you have any questions about the Hopsworks, about the feature store, or any issue that might arise. So pretty active there. Feel free to join the community there as well.
Thank you so much, Fabio. We have a question, and we have some time today, so feel free to send us some questions on the Q&A with the Q&A button. So we had a few questions that our team already answered throughout the presentation, but we have one left that is online feature model. Is it online feature model better than application model?
I'm not entirely sure. Online feature store better than application model. I would say that like the you don't want to embed your model into the application. So I would definitely put it outside and have it like something like KF serving, for instance, that we are integrating to Hopsworks to take care of actually model lifecycle and so on. Same thing goes for features. You want to avoid as much as possible. Actually, that's actually like bad practice to have doing feature engineering within your application, and have the feature engineering being done at the feature store level. And the reason you want to do that is because with a single pipeline, and if you look back at the same this graph, with a single pipeline, you can fill both the offline and the online feature store at the same time. And so you make sure that whatever logic has been applied for creating those features for the model training, the same logic is going to be applied for the online features, basically. And so that allows you to basically keep being consistent between the two, and allows you to be certain that whatever the online feature store is returning is actually compatible with the model that is being served, basically.
Okay, we got one more question. Can it be better than Databricks platform? What can you say more advantage of a feature store?
Well, I mean, Databricks doesn't have a feature store right now, so it's I mean that's already like a big plus. so there are two aspects of it. So if we go directly as a Spark platform, that's the only thing we compare between the two, I would say, considering the lack of feature store in Databricks itself. Um, you can use the Hopsworks Feature Store with Databricks. So you can, if your organization has already adopted Feature Store, adopted Databricks, and all your pipelines are there, then you can leverage Hopsworks as an external tools, and we have support for be able to plug your Databricks pipelines to be able to write into the offline and online feature store. So it definitely does not exclude one of the two. Again, if you're not using Databricks, or if you can also use the Spark environment that we provide. One of the differences that we have seen, and I actually appreciate, I'm biased, but like I appreciate that, is that if I have to change something in Hopsworks, if I want to change the configuration of how this Spark application runs, I don't have to restart the entire cluster. I can, like, you can do it at Hopsworks level. Let me just go and show you. I can just like shut down the notebook that I'm running and create a new notebook with a different, let's say, configuration in terms of storage, of memory and cluster size and so on, or also attaching different dependencies and so on. That's all taken care, and this spin ups in a matter of seconds, not under to wait minutes to a new cluster to get up and running. But that's like, yeah, that's something that is my preference. Then might not be the preference for everybody. But definitely, if you are already using Databricks in your organization, then check out the documentation. We have introduction, and we also have a UI that allows you to basically get up and running and connect to your Databricks cluster. You just have to get a token from your Databricks cluster, Databricks account, and Hopsworks will configure your clusters to be able to interact with the Hopsworks Feature Store. So there's no configuration, like it's all UI driven. There is nothing that you have to mess around with in the Databricks, on the Databricks side. So yeah.
Have a few more questions. Next one is, can you talk a little bit about the implementation and ease of management of the infrastructure?
Come again?
Can you quickly talk about the ease of implementation and ease of management of the infrastructure?
So if you are using Hopsworks AI, we have done a lot of work to be able to like hide away the infrastructure side and to be able to kind of manage it for you on your behalf. So that's a big plus. Everything is monitored. Everything is we already pre-configure alerts. We have tracking, logging, and everything. So the infrastructure team usually start like with a good with a good set of tools to be able to have an insight and observability on the different Hopsworks clusters. If you're running yourself, if you're deploying yourself your cluster, you do have the options to reach out to us as well, and we help out manage the cluster if there are any issues and so on. So if this is if you are deploying, for instance, on-prem, or if you're not using Hopsworks AI and you are running your own cluster. Hopsworks is a kind of a microservice architecture. There are several components that interact with each other. So there is a bit of a learning curve, but like nothing impossible, I would say.
And another question: do you support infrastructure as a code within Hopsworks?
So I would say yes. There is, depending on what you mean. So if you are talking about features, definitely yes. Jupyter notebooks, for instance, is one way that you can use, for instance, Git to track your feature code and be able to version control your features, transformations, and so on. So that's one big plus. If you are referring to just pure infrastructure and Hopsworks, we are launching in the coming weeks a Terraform provider to be able to basically replace all these configurations that you're seeing through the UI through Terraform script, and allows you to basically version control also this side of the Hopsworks management, let's say.
think we ran out of questions, but I have a question for you. You have been working Feature Store for a very long time at Logical Clocks, but when we did the poll for this event, a lot of people are still learning about the concept, what it is. What do you suggest as a resources for people who want to learn more?
I mean, the first one I would say featurestore.org. There is a bunch of videos, a bunch of presentation, both by us and by other companies, especially large tech companies that have built their own feature store internally that allows you to basically have an insight or being exposed to different ideas of like different architecture, different design decisions that have been made by different teams, I would say. There's online meetup that we are also involved with that brings in users and different architects and developers for feature store. So also that one is a good opportunity to learn about it. Our documentation, docs.hopsworks.ai. It's a good place to have a look and to understand the design decisions that we made and how to use it, but also to try it out. Like you probably know better than me. One of the use cases, just go on Hopsworks.ai, pick one of your use cases that you already have available. So already have a model ready, or maybe already a serving model in production. Say, okay, how can I use the feature store to solve the same issue? I would say to start again from scratch. If I have to start again and retrain this model and resolve this business use case with the feature store, how would I do it? And start from there, start learning different aspects of the feature store. And I would say that's the kind of the best way to get started and learn about it again.
Great. I think we have time for one more question that we got. What are the main challenges that you're seeing today?
Regarding the feature store?
I guess so.
I would say the main challenges right now is trying to get adoptions. Try to scale the feature store within an organization. Oftentimes we see that people try it out, but they kind of, like, I would say, lack the internal push for actually adopting it together. Like we see the teams that actually adopt the feature store are happy about it, but they still kind of struggle to kind of have a larger set of companies. Larger set of users within the same company try to use the same feature store. And the benefit of the feature store only kicks in when you have multiple teams working together, and that where really the feature store shines, because then at that point all the sharing of features or using features that I was mentioned before really start like reducing the time you actually spend in developing new models, developing new business case. It's a great tool if you are a single team that, for instance, have this I want to be able to serve my features with low latency and high availability. But it's even better when you have multiple teams on the platform that can basically collaborate with each other and use the feature store and use the feature store together to build better and faster models, I would say.
Okay. And one more question. For those people who are looking into feature stores or consider buying one, what is your number one suggestion that for them to think about it or to consider?
No, I mean, Hopsworks, I would say right now is the leading feature store. I'm of course biased, but that's what we are like sweating to build and to keep like always updated and always at the edge of what feature store is, and try to bring new features to customers, listen to their feedback and so on. So I would say, try Hopsworks out, I would say.
Okay, we have a good question, and I think we have 5 minutes, so I'll ask. How can you be dealing with network security? So can you talk a little bit about security on Hopsworks?
So we have, so if you are considering, if you're talking about network security only, We deployed everything within a single VPC. You can come with your own VPC, or we can let us develop let us create a VPC, depending a little bit on the requirement of IT that you were given. Again, the types of the VPC can be completely closed off, so you can be completely air-gapped VPC. There are a bunch of features that you won't be able to use, like user management and so on, from Hopsworks.ai, but like 99.99% of the platform is going to work if you completely isolate Hopsworks from the network, from the rest of the internet. Regarding the rest of the security, we have an extremely long and detailed blog post that goes into details about the entire architecture of how we secure data, both at rest, in transit, and how do we make sure of data is access is authenticated, authorization is enforced, and the actions are actually tracked. That is done by using certificates. So different services and different users within the platform have their own certificates. The certificate management, again, is one of the things that the platform takes care, is hide from the user, and that those certificates will be used both for authentication and authorization. But if you go on logicalclocks.com/blog, you find the blog post I'm referring to, and you can dig more into details of how we secure different systems and how different systems interact with each other, and so on and so forth. So that's, I would say, a webinar by itself. But yeah, in general, yeah.
We already shared the link on the chat, so if you want to check it out about security in Hopsworks, you can go there. I think we're going to end for today, but thank you so much for those who stayed with us until now. And don't remember that if you want to try Hopsworks on your own, you can do so for free. Go to hopsworks.ai. But if you also want to talk to us and have a demo and walk through your specific infrastructure, feel free to reach out to us as well. And that's great. Thank you so much, Fabio. It was a very interesting presentation.
Thank you very much.
Thank you. Bye-bye.
Bye-bye.